So we have a circular cross section bar of this diameter of the bar is 5. So that is given, and it is acted with a load of, just imagine this fixed at one end, it is acted with a pull that is given as axial pull is 45 kilonewton. Axial pull is 45 kilonewton. So this is the load acting on the bar, and the material, the bar material is having a Young's modulus E. Young's modulus E, that is given as how much? 2 into 10 to the power of 5 Newton per mm square. 2 into 10 to the power of 5 Newton per mm square, right? Yes. So we have 2 units in mm, and this length is in meters. So convert this meters to 2 into 1 meter, that is into 10 to the power of 3 mm. 2 into 10 to the power of 3 mm, right? So these are the given data. You need to find out what you just checked. You need to find out, the first is stress, strain, and elongation. Stress, strain, and elongation. The stress acting on the bar is sigma. The strain is, in some books, it will be taken as E, Greek symbol, or small letter E also. Right? You need to find out. Then elongation. Elongation is staging length. Delta L. Delta L, or even they take it as small delta L, both are same in some of the books. So these things you need to find. Right? So we have a participant here. So how to find? I just ask the questions. So Aishwarya R is here. So if you are not answering, I'll mark it as absent. So if somebody is not, I am calling here the names. So if you are not answering, so this class will be marked as absent. So if you are in the meeting and if you just put it and gone somewhere, it will be not considered. So Aishwarya, yeah, please answer me. How would you calculate? You taken the question, right? So you're taken the question, first problem. So it is a basic problem you might have solved in mechanics in the first civil. So how to calculate these unknowns? So you have taken the problem, right? Problem statement has been taken. So how to calculate the stress, strain, and change in length? So what equations to use? You please tell me. So you have attended the previous classes. You know the equations, right? This is a basic equation. So how to calculate the stress? So stress is given by what are the equations that is given for the stress? Stress is given by what equations? ಗೊತ್ತಿದೆಯಾ ಗೊತ್ತಿಲ್ವಾ? Know it or not? So Akash RS.
Sir.
Yeah, stress. How to calculate find the stress? What are the equation for stress? So if you don't know, yeah, please.
Stress is equal to force acting per unit area.
Yeah, that is right. Just a basic equation I'm writing somewhere here. Yes, you know that stress is given by, so you need to write it by general equation for stress. So that has to be written. Equation for stress, it is given by sigma. Sigma is equal to force by area, right?
Sir.
Sigma is equal to force by area. So you know this one of the equation. So if there are other equations also for stress, you know the Hooke's law, right? So by Hooke's law, stress is given by what? Sigma is equal to? Akash.
Sir.
Yeah, sigma is equal to what according to Hooke's law? According to Hooke's law, stress is proportional to strain, right?
Yes, sir.
So and also we know that sigma is equal to, according to Hooke's law, so we'll take E as small letter E into capital letter E. So that is Young's modulus. So this is also one more equation for stress, right? Alva, stress is
Yes, sir.
proportional to strain, and this
Strain.
proportionality constant is modulus of elasticity.
Elasticity.
Right. ಇನ್ನೇನಾರ equation ಇದೆಯಾ for stress? ಇಲ್ಲ ಅಲ್ವಾ? So these are the two basic, okay, you can mute Akash. So these are the two basic equations for stress. So in your problem, they have asked you to find out the stress, strain, and change in length. Change in length. So what is the problem statement? There is a bar of circular cross section. It is applied with the axial load, and it is, we have fixed it one way. So it is applied with the axial load of 45 kilonewton. And there is a diameter of the bar is given. So, and also we have a modulus also. So you can use which of the equation out of these two. So in out of these two equations, I know force and also I can calculate area. So if I use the other equation, I don't know the strain. Strain I don't know. So I cannot use this equation. So I'll be using the force by area. So sigma is equal to force by area, you calculate. You need to calculate the area first. Area is given by, since it is a circular cross section, it is pi d square by 4. Calculate area. I will be not writing any answers here. So you need to write the answers, upload all the problems solved in the assignment. I will be making the assignment portal in Microsoft Teams. If you are doing, as I told, you need to do along with me. So I will be not writing any answers. You have to write the answers. So I'll just give the steps how to solve the problem that you need to do it. So you calculate the area. Area is pi d square by 4. So area is pi d square by 4. But be careful in problems. The units should be a single unit. So I have already converted all the units to mm. So you will get area in terms, some value in terms of mm. So substitute that force by area. Force is directly given. So you substitute force in terms of newtons. In terms of newtons, take kilo as it is 45 into 10 to the power of 3. 45 into 10 to the power of 3 divided by area. Area is how much it comes, I don't know. So then you find out stress. Stress you will get in terms of Newton per mm square. Area I will get in terms of mm square. So this will be Newton per mm square. So that is, I got the first value. Next it is strain. You need to calculate the strain. So next we have how to calculate the strain. So we have already the equation here. So since we have one more equation based on the Hooke's law, you can use this equation. You can use this equation. I think you have taken the problem, right? Right. By Hooke's law, okay, this is by Hooke's law. Sigma is equal to small letter e, that is strain into capital E, modulus of elasticity. So then you can, by this previous expression, I will be getting the stress value. In the problem, they are given the modulus. In the problem, they are given the modulus. So the only unknown here it is strain. You find out the strain. So strain is equal to sigma by E. So you find out what value is this. So strain is unitless. Since sigma is same unit, E is same unit, it gets cancelled. It's just a number you will get, right? So you find out the strain, small letter E, right? The another unknown is change in length, delta L. How to calculate delta L? So what is the equation for strain? Abhishek. So we have Abhishek here. How to calculate the strain? So it's a basic problem based on the basic equations. So Abhishek is not here. Abhishek.
Sir, network correct ಆಗಿ ಬರ್ತಾ ಇದೆ.
ಕೇಳಿಸ್ತಾ ಇದೆ ಮಾತಾಡಪ್ಪ. ಕೇಳಿಸ್ತಾ ಇದೆ.
ಸರ್ ನೆಟ್ವರ್ಕ್ ಕರೆಕ್ಟ್ ಆಗಿಲ್ಲ ಸರ್ ಇಲ್ಲಿ.
ನೀನ್ ಮಾತಾಡ್ತಾ ಇರೋದು ನನಗೆ ಇವಾಗ ಕೇಳಿಸ್ತಾ ಇದೆ. ಸಾಕು ಹೇಳು ಇಷ್ಟೇ ನೆಟ್ವರ್ಕ್. Right. So how the strain is given by what equation? So general equation for strain is right. So or anybody else? ಬೇರೆ ಯಾರಾದ್ರೂ ಇದ್ರೆ ಹೇಳ್ಬೋದು. Yes, other than Abhishek, ಬೇರೆ ಯಾರಿದ್ರ? So we have so many participants here, 25 of them. So anybody can answer. So strain is given by
change in length per unit length.
yeah. So basic equation for strain, we know that equation for strain. So general equation for strain, we have that E. So E or epsilon on the counter, it is both the same. In some books, you will be taking E or not epsilon, that is Greek symbol E. So it is given by delta L by L. So from the problem, what is L? L is the initial length before applying the load that is given in the problem. So and by the previous solution, we have the strain value E. We have the strain value E. From previous solution, we have a strain value that has been already found out. So substitute in this equation. So we will get delta L. We can find out delta L. Delta L is equal to E into L. So you will get change in length in terms of mm. You find out that. You find out. So be ready with the solution, with the problem. Problem baribeku. Sheet of paper, whatever the problems we solve. So keep it ready. So I will just prepare an assignment. Yavaga submit anta irutte. So when the due date irutte, within that date, all the problem together, you just scan it, and you need to upload it. Right? Helidini munchene. So otherwise, if somebody has done the answers, you can tell me. So what is the value of sigma? Somebody has solved. So I'll write the answer.
91.662 Newton per meter square.
Yeah, right. Sigma is 91.662 Newton per meter square. Yeah, you calculate the diameter area Kotila values, you calculate area. Then what is the value of strain?
4.5.
0.4583.
Yeah, strain it is E. So strain is point. Is it?
4583.
0.453 10 to the power of into 10 to the power of minus ಏನು ಬರುತ್ತಾ ವ್ಯಾಲ್ಯೂ ಅಷ್ಟೇನು
ಅಷ್ಟೇ ಸರ್.
instead of
0.4583.
0.4583. So that's it. Then we have a change in length value. ಎಷ್ಟು ಬರುತ್ತೆ change in length? What is change in length?
0.9166 meter.
0.9166 meter.
Meter.
Meter ಮಾಡಿದ್ಯಾ?
Into 10^3 mm.
ಇಲ್ಲ 0.9166 mm ಅನ್ಸುತ್ತೆ ನೋಡು ಒಂದ್ಸರಿ.
Yes, sir.
That is 0.916 mm. So what about strain value? Correct ಇದೆಯಾ? 0.4583 ನಾ? ಗೊತ್ತಿಲ್ಲ ನೀವು ಹೇಳಿದ್ ಬರೀತಾ ಇದ್ದೀನಿ. Just look at
4.
the unit. Yeah, unit should be similar units. Before solving any problematic subject, convert all the units to single unit. If it is in meters, follow in meters. If it is in mm, follow in mm. Right? So it is a general problem. So and also we have the other equations also. We have another equation for delta L. So we have another equation for change in length. So that I just for your note I will be giving. So like so we have a stress equation. It is force by area, right? Force we in some books they will be taking F na, they will be taking it as P also. F or P ಎರಡು ಒಂದೇ load P ಅಂತಾನು ತಗೊಂತಾರೆ ಇಲ್ಲ F ಅಂತಾನು ತಗೊಂತಾರೆ. We will take it as P follow ಮಾಡೋಣ. P by A. This is given by P by A or F by A, both are same. So we have the expression for stress is force by area, and we have a expression for Hooke's law. By Hooke's law, we have strain is equal to this value sigma by E, right? So and we have change in length value is E into L. So by this expression, so we can write delta L is equal to, and just for my reference, I'll be calling this as equation 1 and this has equation 2, right? So by equation 2, I substitute E. So E is equal to sigma by capital E, right? And L into L into L. So this is by 2. So this is only for your note by equation 2. Then by equation 1, we have stress is equal to P by A or F by A. So substitute this stress value in this equation also. By equation 1. So we can write delta L is equal to sigma is equal to force by area. So sigma is P by A into Young's modulus. So this is also one more equation that you need to remember. Delta L is equal to PL by AE, PL by AE. So if you substitute in this equation also, we know all the values. I know the load acting it is 45 kilonewton, length also know, area also know, modulus also know. You will get a same expression. You will get a same value for change in length. So remember this equation also. This is only for your note. So that will be using in the next classes for varying cross sections. Derivations there will be using that equation. Delta L is equal to PL by AE. P is the applied load, L is the length of the specimen before applying the load. A is area of the cross section. E is modulus of elasticity. Right? So it is finished, right? First problem. So you can take any doubts in this. Can ask.
Sir, strain power -3 ಬರುತ್ತೆ sir.
Strain
10 raised to -3.
0.4583 into 10 to the power of
-3.
ಅದೇನು ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇದೆ ನೋಡಿ ನಮ್ಮ ಹತ್ರ ಇಲ್ಲ ಇಲ್ಲಿ that you need to do it. Just simple. Sigma is in Newton per mm square. E is also in Newton per mm square. Just divide ಮಾಡಿ ಏನು ಬರುತ್ತೆ ಅನ್ನೋದು into 10 power minus. Right? So better you do it along with me. Anyway, you need to upload that as an assignment, right? Soon after this. So when I say, okay, you can take the next problem. So is it visible, right? Second problem. Really. The second problem, a mild steel rod of 12 mm diameter, was tested for tensile strength with a gauge length 16 mm, Following were the observations: final gauge length 78 mm, final diameter 7 mm, ultimate load 61 kilonewton, yield load 34 kilonewton. Calculate yield stress, ultimate stress, percentage reduction in area, percentage increase in length, and allowable stress. Take factor of safety as 2. So in the meantime, attendance is visible. You can mark the attendance poll also. So this is the second question. So these are the basic problems. You may not get these problems. The module 1, you have a number of topics, but it is easier, but it is lengthier. You have so many varieties of problems in module 1. But it is compulsory. You need to attend 2 questions from module 1. Taken the problem, right? So I'll rub this. So remember this change in length equation will be using many of the times throughout this subject. So many topics. Data is given by also in that PL by A. Okay, so you have taken the problem, read the statement, what all the given data. First, you just note on the given data and what to find, just mark it. So when you write that, so after the problem, you will come to know what are the things that you want to do. So in any problematic subject. The first thing is they are given a mild steel rod of 12 mm, same thing, just like a tensile test. So there is a tensile test is conducted on a mild steel rod of 12 mm diameter with a gauge length of 16 mm. So they are given diameter of the rod. So it is initial, we'll take it as they are given initial and final. So we'll take it as di. Initial diameter as di. So how much initial diameter di? Initial diameter of the rod. So we'll take that as di is 12 mm. Then initial length. So you can take small letter L or small capital L both. Initial gauge length will take it as Li. How much? 16 mm. 16. Then we have the final length, that is gauge length. It is final line and diameter is given. So final length will consider as L0. L0 as 70. $78, right? 78. Final it is 78 mm. Then final diameter D0, we'll consider it as final diameter after testing. It is 7 mm. 7 mm. And ultimate load it is given. So we'll consider the ultimate load that is given in the problem. So we'll take P for load. Ultimate K we'll take suffix, the prefix as what? PU, ultimate U. So we'll take PU. Ultimate load is 61 kilonewton. Then we have yield load also. Yield load 34 kilonewton. We take that as PY 34 kilonewton. Right? So you need to find out what you need to find out? Yield stress. You need to find out yield stress. So that is sigma Y, comma, ultimate stress sigma U, comma, then percentage reduction, percentage elongation, that is percentage reduction in length, percentage L, comma, and percentage area reduction in diameter. You need to calculate. And also they are given factor of safety, FOS, as 2 in the problem. So this is a given statement. Factor of safety is given as 2. So since they are given the diameters, initial diameter, final diameter, find out the areas, initial area and final area, initial area as well as the final area. Find out the initial area as well as the final area. So these things you need to find. So right. So since DI is given, find out AI. initial area, you need to write in sentence, initial area of the rod AI, final area, that is L0 ಅಂತ ಬರ್ದಿನಲ್ವಾ? So we'll just take it as LF, LI and LF will follow. DI, DF, initial and final. So it is AF, A small letter F, suffix. So find out initial area, it is, and calculate ID, DI square by 4 is 5, DF square by 4, final area. How much it comes, you just note down. So it is in mm square. mm square. This ಬರುತ್ತೆ ನೋಡಿ. Right? So I need to find out what yield. First point is yield stress. So if you want to calculate stress at any point, so yield stress unit that is given by sigma y. So that is equal to yield load. Yield load is Py by area. So since we are finding that engineering stress, so we will be using only the initial area of cross section. Initial area of cross section. If it is a true stress, we will be using the final area cross section. So it is Pi by here, Py by Ai. Since it is only engineering stress, so since they have already given yield load, so yield stress is equal to, stress is general equation, it is force by area. So yield stress, the load at the yield point divided by initial area. So if they have asked you to find out the true stress, then you should have used in the final area. So it is only general stress. So we'll be using initial area of cross section. You find out how much it is, I don't know. So next is, second one is, I need to find the ultimate stress. Ultimate stress is sigma u. Sigma u is equal to ultimate load P u by area is always initial cross sectional area. Unless it is true stress, it is initial area of cross section. So find out how much it is. So it is in same value will be, don't forget to write the units. It is Newton per mm square. So here also it is Newton per mm square. Right? So next I need to find out the percentage elongation in length, percentage reduction in area. So if somebody has found out, you can tell the answers. Dira, Madidira. So what is
Sir, yield stress 300.59.
Yeah, yield stress is 300.59
Newton per mm square.
Newton per mm square, right? Then ultimate stress find out. Sure. 150 na.
1.8584 into 10 power plus 3 Newton per millimeter square.
Where?
530.3.
Yeah, it is 530. Yesterday 5.
39.39.
38 or 39?
39.
Yeah, 39.39. Yeah, 39. It is right. Newton per mm square. ಅಲ್ಲಿ ನೋಡಿ ಯಾರು ಒಂಚೂರು ಯೂನಿಟ್ಸ್ ಎಲ್ಲ ಮಿಸ್ ಆಗಿರುತ್ತೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಅಲ್ಲಿ, ಏರಿಯಾ ಎಲ್ಲ ಏನೋ ಮಿಸ್ ಆಗಿರುತ್ತೆ, ಯಾವ್ದು ಕರೆಕ್ಟಾಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. Substitute, it is initial area of cross section. So 538, it is right. So next one, it is percentage reduction in diameter. Percentage reduction in diameter, that is equal to, so that is initial area AI minus final area AF divided by initial area into 100. You calculate how much percent. Similarly, next one is percentage increase in length. Percentage increase in length. So it is given by LF, that is final length minus LI initial length divided by initial length. Calculate. So the lastly, they are not given anything like, if it is asked to find out the factor of safety also, you can find out. Also find factor of safety, you can find out. Since it is what they given mild steel, right? Mild steel it is ductile. Mild steel is ductile. Mild steel have the material put together. Yeah, mild steel. Since mild steel is ductile, the factor of safety is given by FOS. Since mild steel it is not asked, just for your understanding, if it is asked in any question, is ductile. Factor of safety is equal to sigma y by sigma d. Sigma d is design stress. The factor of safety, it is given in the problem, right? If you want to find out the design stress or allowable stress, find out sigma d. Sigma d is known as allowable stress. You can calculate. Since factor of safety is already given, you can calculate sigma d. So percentage reduction, these equations you need to remember. Percentage reduction in diameter, percentage increase in factor of safety equation, you know. Since it is ductile material, it is yield strength to design stress. If it is brittle material like cast iron, it was sigma u by sigma d, cast iron. Any other brittle material. You just add it. Also find the allowable stress. Also find the allowable stress or design stress. So it's been percentage reduction in diameter. What is the answer?
$193.9.
Percentage reduction in diameter is percentage only.
65.9.
Yeah, it is 65.9.
65.97%.
65.97% into 100 mark. So increase in length, how much?
387.5.
Percentage.
Yes.
87% ಬರುತ್ತೆ.
Yes, sir.
So LF minus initial length is 78 minus 60 is the final length is 78, initial length is 60.
60.
Yeah, divided by 60. How much?
387 above.
387 or 38.7 percentage. 38.7%. Correct.
387.5 ಬರ್ತಿದೆ ಸರ್.
ಹಂಗೆ ಗೊತ್ತಾ ಎಷ್ಟಾಗುತ್ತೆ ಇದು 18/60 is how much? 18/60. 18/60 387 ನಿಮ್ಗೆ ಬರೋದೇ ಇಲ್ಲ, ಚಾನ್ಸ್ ಇಲ್ವಲ್ಲ. %30 ಬರುತ್ತೆ ಅಷ್ಟೇ ಕರೆಕ್ಟಾಗಿ ಆನ್ಸರ್ ಅಲ್ವಾ? ರೈಟ್. ಇನಿಷಿಯಲ್ ಲೆಂತ್ 16.
38%.
38 ಬರಲ್ಲ ಸರ್. 16 ಇರೋದು ಅಲ್ಲಿ ಇನಿಷಿಯಲ್ ಲೆಂತ್.
60 ಕೊಟ್ಟಿಬಿಡಿ, 60. It should have been 60 ಆಗಬೇಕಿತ್ತು. 78 minus 16. ಸರಿ. ಆ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಇದೆಯಲ್ಲ ಅದು ತಪ್ಪಾಗಿದೆ. ಇಟ್ ಕೆನಾಟ್ ಬಿ ಸೋ ಮಚ್. ಮೇಕ್ ಇಟ್ 60 ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್. 60 ಮಾಡ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. ನೆಲ್ಲ ಯೂಸ್ ಮಾಡಿಲ್ಲ ಅಲ್ವಾ ಇನಿಷಿಯಲ್ ಲೆಂತ್. ಸೊ ಮೇಕ್ ಇಟ್ ಆಸ್ 60 not 16. Some mistake, typing mistake ಆಗಿದೆ. So right, it is 60. Initial length is 60. So ಅಷ್ಟೊಂದು increase ಆಗಲ್ಲ. So 60 to 78 it can be 16 to 78 ಆಗಲ್ಲ. Right. So make it as 60 initial length in the problem. 60. So it would be something ಎಷ್ಟು ಬರುತ್ತೆ 30% ಏನೋ ಬರುತ್ತೆ. Right.
30 sir.
Yeah. So make a correction in the problem. Make it as 60. So practically it cannot be that much elongation. So it should be 60. So next you can find out the allowable stress or design stress, sigma D. So since it is ductile, it is sigma Y by design stress. If it was brittle material, it should be factor of safety will be equal to sigma U by sigma D. This bartha calculate ಮಾಡ್ಕೊಳ್ಳಿ sigma D. Okay.
150 point.
Just bartha ನೋಡಿ, just calculate. Okay. So we just so if it is finished, any doubts idra you can ask, or else we will continue with the next class. So it is full of problems and derivations from here on. There is no very written theory. That was first 2 classes in full problem set. So you need to do along with me if you want to go through with this subject. Illa andre kashta agutte. Right. So we'll go slowly itself. So we'll just solve it on the board. Matte extra irado you need to do it by yourself. I'll just share the book also. One soft copy book ide, that is your reference book. So the teams you can refer. Aita. Entire syllabus is with that textbook itself, R.K. Bansal. I will just upload today this PPT as well as book to soft copy, or else it is available in Google also. You can download a book, reference book, R.K. Bansal, Mechanics of Material. So if it is finished, you can exit. Doubts ಏನಿಲ್ಲ ಅಂದ್ರೆ can exit. ಅದೆಲ್ಲ ಬರ್ಕೊಂಡಾಯ್ತಾ? ಬರ್ಕೊಂಡಾಗಿಲ್ಲ you can take down. 2 ನಿಮಿಷ ಟೈಮ್ ಕೊಡ್ತೀನಿ, you can take down. So ಯಾರ್ಯಾರ್ದು ಮುಗಿದಿದೆ you can exit.
ಸರ್ yield stress 883.57 ಬರುತ್ತೆ ಸರ್, ತಪ್ಪಾಗಿದೆ.
Yield stress. Yield stress is yield load. Yield load is 34. So initial area cross section. ಇಲ್ಲ ಕಣ ಕರೆಕ್ಟ್ ಇದೆ. ಈ ಲೋಡ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀಯಲ್ಲ, ಇಟ್ ಶುಡ್ ಬಿ 61 into 10 to the power of 3 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಬರೀ ಈಗ 34 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಡಿ. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದ ಯೂನಿಟ್ಸ್ ಇನ್ ನ್ಯೂಟನ್ಸ್ ಲೋಡ್ ವ್ಯಾಲ್ಯೂ. ಇದು ಕರೆಕ್ಟ್ ಇದೆ ಅಂತ. ಆಯ್ತಾ? ಕ್ಲೋಸ್ ಮಾಡ್ಲಾ? ಸರಿ, ಅವ್ರು ಬರ್ಕೊಂತಿದ್ರ. So keep all the problems ready. I will just ask when and how to upload in the Teams. ಅವಾಗ ಅಪ್ಲೋಡ್ ಮಾಡಬೇಕು. ತುಂಬಾ ಈಕ್ವೇಷನ್ಸ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಆಸ್ when the equations are appearing, new equations ಒಂದ್ ಕಡೆ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಜಸ್ಟ್ ರೈಟ್ ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ನೇಮ್ ಏನ್ ಈಕ್ವೇಷನ್ ಅಂತ ಅದನ್ನ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ, ಇಲ್ಲಾಂದ್ರೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ನಂಬರ್ ಆಫ್ ಈಕ್ವೇಷನ್ಸ್ ಇಲ್ಲೇನೆ. like stress equation, then percentage reduction, increase in length, factor of safety equation, ಮತ್ತೆ last change in length equation. So ಇದೆಲ್ಲ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಒಂದ್ ಕಡೆ. This state, so otherwise this subject ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ ಅಷ್ಟೇ ಇಲ್ಲ ಅಂದ್ರೆ at the end. So ಯಾರ್ದು ಇಲ್ಲ ಅಂದ್ಕೊಂತೀನಿ. So I'll just close this. So if you mark the attendance, you can exit. Attendance already ಆಗೋಗಿದೆ.